Hello, everyone. It's Jihao again. I'm the co-founder and CEO of Genia. Welcome to another episode of our new podcast. Today, we're really excited to have Jesse Light and Cole Fowler, both from SML. These are very experienced, not only structural engineers, but also now AI leaders in the structural engineering world. So Jesse and Cole, great to have you on this podcast.
Yes.
Thank you.
Yeah,
Appreciate being here.
Pleasure. Exactly. Pleasure to be here.
Awesome. So, Jesse, why don't we start with you? You have a very amazing career working on many types of projects. Why don't you tell us a little bit more about yourself, your background, your journey so far to now leading SML overall?
So I started out as a mechanical engineer and then got into track home design and built my way up to structural engineer. I dabbled a little bit working for Orbital Sciences back in the day doing some mechanical test engineering. And because I was a mechanical engineer, I did some computer programming and also just understood how factories worked and how much automation there was in that system. And because we started dealing with a lot of manufacturers, we started figuring out ways that these manufacturers would build systems that we had to apply building code to. And so it kind of really started to flow where we're like, okay, we have manufacturers that are wanting kind of a streamlined process that they can repeat over and over again. But we have to be able to apply the structural engineering components, the mechanical engineering components, and then this automation and software engineering components. So now we're kind of wearing three hats. We're wearing the mechanical, structural, and software engineering all in kind of one, and creating this repeatable automation workflow for multiple clients.
Wow, that's pretty amazing. I mean, it's not really, I would say, conventional for structural engineers normally to stump into automation, because I think for most of the projects that we do, it's typically project by project, right? So it's really amazing that you identify the repeatable patterns and apply some automations to that. Cole, let's get to you. Can you tell us a little bit more about your background?
SML was my first job out of college. I went to ASU civil, so I didn't do a mechanical. I didn't do any of the pivots. And I know that when I was at ASU, I did some work coding using MATLAB. And
wow.
I think that's a basis for some of the things that I've started to do at SML and the automation paradigm as a whole. So I know that when I come up with reasons to automate, it probably stemmed from my background in education from when I got my degree.
Absolutely. Jesse, when the two of us first met at the NCSA event, you were giving a talk to fellow structural engineer peers in the audience, explaining those cool, amazing automation systems that you have built within SML. Can you tell us a little bit more about that and where that inspiration came from, how that become the SML advantages nowadays?
So we realized that most of the structural engineering software that we were using, they were built by different companies. So they weren't really intended on working together. And what I was noticing is as we would step from one software to another software to another software, as we'd go through our flow, our workflow, there was a lot of data entry that would happen between each one. And that was where most of the errors would creep in. You know, we're really good at doing engineering judgment, but when it came down to actually putting in all the data, you know, your fingers just stumble and your brain kind of starts thinking about other things sometimes. And suddenly, you know, all these errors creep in. And we were trying to figure out how can we kind of create a system where the data flows from one software to the other. And I started talking to Cole, and we realized that there are some ways to get data exported and imported in between some of these software. An example was RISA 3D. They had a way for you to export your RISA 3D file into an SAF file, which was really an Excel file. And so every piece of the RISA model was a different tab in the Excel file. And because we're using MathCAD, we could develop all of our loads, and we could take an old RISA model with new loads, override them, and create a new RISA model. So we could do these manufacturing projects where we had this same exact product at 20 different locations all over America, and we could quickly get the information back and forth between the systems and kind of automate that. When I was at that conference, we were kind of actually talking about AI and how that would work in this
Right.
system. And that's
Right.
kind of why you were there. And what we were realizing is all the way along this process, when we first started, AI is just barely creeping in. And it took us a lot of time going to all these forums and trying to figure out how to get these things to talk to each other. We had to talk to other people about this stuff, which was great, but it was
Imagine.
slow and tedious. And
Right.
so what we realized is that as the different AI systems kind of progressed and got better and better, you could
Mhm.
tell the AI kind of what I was trying to do, and it would come up with a step-by-step process of how to accomplish that task. And then you could break those up into different steps, or more steps, and just kind of tick them off one at a time. And every time you'd hit an error, you would tell it how to, ask it how to fix the error, and it would fix it for you. And so
Right.
suddenly you've got like an AI process, but every step of the way, the calculations are definitive calculations. There aren't
Mhm.
any calculations. They're all based off of code, so
Mhm.
that calculation doesn't change. It's how do you get the information to flow through a workflow automatically and between all of these different programs that we were
Right.
really interested in. And that's how we applied it internally for us so that we could get all the data to flow front to back, side to side, and have the engineer not have to be a data entry specialist. They're using their engineering knowledge to do the workflow, but not necessarily having to type in every number.
As far as what I've done, I talked about a little bit of my background. And when I was first starting out, I was noticing these tiny little annoyances when I was working. It was just stuff that I wasn't sure if it was part of the role of being an engineer. It was like I'd see it on every project, and I'd think to myself, well, I don't really want to do this every time, and it would start to eat away at me. And at one point, I realized that I really wanted to act on resolving these annoyances, getting away from doing these tiny repetitive tasks each time I do a project, because it was sort of taking the fun out of it, having to do them each time. And what makes my role at SML different than other engineers who's starting out a different structural firm has been that SML has allowed me to act, to actually try and fix those annoyances. I'm guessing that at another firm, a larger firm, there are engineers who experience these same annoyances, but when they bring them up, they're shot down because it's more of the structure of the workflow that matters to their higher ups than getting the workflow done in a different, more efficient way. That's what has been different for me growing my career early at SML.
Both Jesse and you mentioned that the tedious part of the job, doing data entry across different software, has been occupying too much time. You also mentioned that having access to automation tools has been immensely helped your career advancement. Can you walk us through a little bit more of that? Like, what's that
Yes.
experience look like? I'm pretty sure you still probably need to do some calculations by hand, but how do you balance gaining the intuition within the structural engineering space with the automation aspect?
The active checking in itself is a way to practice engineering. And I think it really has merits. Just now I was helping somebody who hasn't done something in a minute do some seismic calcs. And I think it helps stretch the brain and it keeps you in good form as an engineer. But there are different things to check that take different amount of energy. Performing data entry, making sure that you put the right load in the right spot, or making sure that you have the right magnitude of a moment. I don't consider that really to be engineering. It's more like ensuring that you've used the UI of this program you're using correctly.
Right.
And it's one of those annoyances that I was talking about. I don't want to be checking numbers. I want to be solving engineering problems. And the process that Jesse was talking about, that SAF file, eliminates our need to check a bunch of different loads in RISA once we've got the thing set up. I no longer need to see if I've got 18 loads in the right spot on my member, or if I put my load upside down, or if I put the gravity load in the wrong direction, because I've automated that process. And it allows me to devote more energy to solving problems I want to solve rather than the problems that I have to solve.
Gotcha. That definitely makes sense. Automation tools definitely open up more iteration opportunities and help with the career advancement. But from SML's standpoint, what kind of advantages does that give to you guys as a firm? Does it allow you to work on more projects? Does it allow you to return higher quality drawings? What does that outcome look like?
The less time I need to devote to a project, the more productive I can be. I'm making the same money in less time. And I think that automating and reduce the amount of effort it takes to make the same impact on a project help the firm grow in that regard. If you have a more productive engineer, they're making you more money technically, or they're doing more work, they're adding more value. I can give you an example. We had a client that for a long time was our largest design client, and we were not doing so well in those jobs as we should have. We were doing a lot of them, but they were taking a lot of time and they were all similar. I was allowed to attempt to solve the problems that I was seeing using these automation tools for the processes I identified. And that design client went from being a money pit to one of the most important role model client at the firm. It's the kind of relationship we want more companies to have with us, because if we can do things for them quicker and quicker each time, and we're adding value to them, it's no longer a matter of cost. Of course, it's always a matter of cost. If I can cost the least amount I can, it helps them in the long run too. But if I can establish my relationship with firms on a basis that I can give them a better product because I'm quicker and more productive than other engineers, then that's the goal I want to have, because I can navigate away from costs, and I can make it about how good we are and not how cheap we are.
Gotcha. And what does that faster turnaround mean for the client? Timing is money in our industry.
Yeah, there are some firms that are on a very tight schedule. Some contractors, some fabricators that need things very quickly.
Sure.
And when it sometimes isn't a matter of money, if you can't get something to them on time, they drop you. And to be able to satisfy those kind of clients by reducing the amount of time I have to give for a project opens up a realm of industries that I can access that I might not be able to access because I couldn't do such a complicated analysis, or I couldn't do the same amount of work on my drawings.
Mostly it allows for us to have high repeatable processes with low error rates. It brings up our speed, and it also allows us to carry more information across different softwares. In the past, we had to kind of pull envelope loads from one software to put them into another software. So we lost fidelity across all of our calculation process. And that meant bigger sizes for our clients. And when they're manufacturing thousands of these things, every time our base plate was just a 1/4 inch thicker, that was adding money, not only just for the manufacturing, but then shipping. So having us be able to get all of the systems to talk and automate and everything really did bring down our sizes. And it added value to our company because it reduced the amount of time it took to do the process, but it also added value to the clients because they got a system that's highly repeatable. 4 different people could run the same project and they would end up with the same result every time. Plus, all the sizes are a lot lower, so everything on their end was more cost effective.
Absolutely. So just to summarize, with these automation tools that you build internally, it gives you advantages over not only the faster turnaround, but also reliable, more cost-efficient designs. I want to switch gear a little bit to talk about our collaboration. I think we have been collaborating up to this point on a few projects, mostly in California, I would say. So can you maybe tell us a little bit more about our collaboration? What kind of projects have we worked on? How does that new process look like for you guys?
First off, Jesse met you and Robin Calvin over in New York last year.
NCSE.
And so far, we were talking together about what we could do, and you found a group of individuals on the West Coast who are looking for engineers to design accessory dwelling units, ADUs, structures you can put on a lot that already has a house that people can live in. And we've found that these ADUs generally are less complicated, more simple than the houses that are already on the lots. And what that means for us is that we can use a lot of the same kind of details, drawings, calculations to design these ADUs. And for a long time, ADUs, especially on the West Coast, have been relegated to this very fine-toothed design that a lot of engineers specialize in. And what we found working with you, Jihao, is that we can start to enter those markets again by utilizing your system, which saves us time developing the calculations and even the drawings. That's what we've done so far. We've done a couple of ADUs with you, and we've partnered with a couple of clients with you to enter that market in San Diego, which I wasn't really even thinking was possible until you brought it up to us.
Sure, amazing. When both of us were speaking to the client, their head of design was mentioning that he's currently getting the drawings in a 2-3 weeks turnaround. And I think we did something amazing, cutting that time to sealed structural drawing to 5 business days. And our aspiration is to get it down further down to 2-3 business days, right? So walk us a little bit through how the process is different for a traditional firm who's doing it manually. What does that process look like, and how we're now getting it done by partnering together?
Yeah, there's no doubt in my mind that the firms who do this all the time have made their own efficiencies, who have done things a certain way, who always have their plans in a certain way. And that's probably how they're doing it. Very quickly, you've helped us establish this system that it usually takes a lot of time and energy and experience to create.
Right. So oftentimes when you figure out, I have a client that does a repeat type of product. It takes many projects and maybe a year or two to kind of go through enough of them that set all the standards and create like the path forward. Working with you, what has really been great is that we took a lot of time for the first project, but because now we have kind of this AI system involved, we were able to take that as a standard and start replicating it very quickly. And within one iteration, we stepped from, let's say that it took us 20 hours on the first go, then we were down to 10 hours, and then the next one we're down to 5 hours. In like 3 steps, we're already taking that time crunch and moving it down to a very short window. Where before, the thing is that I probably would have had 3 different engineers working on this, and all 3 of those engineers would do something slightly different. And unless you set this process up perfectly to begin with, now you have people going in different directions, and it's really hard to corral that and get everybody back on the same page and going in the same direction. Your system will allow us to do that. It knows, hey, I have this past experience. I want to do this same type of methodology going forward. And because we're working directly with you, we are able to tell you where we're seeing possible improvements. You are able to go in as a developer and literally make those improvements live as we speak. So this kind of iterative process we're doing is like within the project, not between projects. So that's taking that time period and shortening it down into a much smaller window. And that's going to be fabulous. So I really think we could do these all over the country, frankly, because once you kind of have that standard in place, it would just be about, okay, the different regions. You know, if we had high snow region, we had high wind region, we had high seismic region. We've already done the seismic one. Now let's go ahead and like crack the snow load one, and then let's crack the high speed one. Once we have all 3 of those versions, we could do these all over the country, you know, by the dozens. And we could literally be probably turning around, and if we could get like 3 or 4 of our engineers working on these things, we could have, you know, 4 a week going out or more very quickly. And so we could be doing like 200 or more a year within probably just a couple of weeks if we were able to get the clients that wanted to focus on those things. So, and what I really also like is I think that we could go one step further with your system, and that is kind of build some standards. And that model would be already basically pre-engineered, and we could start spitting this thing out all over the country. It's so expandable because you're developing it. And as a developer myself, I have my own websites that I'm developing. And once you know how to get behind the scenes and actually manipulate the software to do whatever you want, suddenly it only takes like a week or two to make wholesale changes and make it do a dramatically improved process. Where if you're waiting for a third party developer to do stuff, and they have competing interests from 20 different clients, right? So they only pick the top 5 to do the development. Where like if you're down here where we're a small firm, they're not going to cater their development to us, but you've really kind of helped us do that. And so I really want to thank you for being able to partner with us and listen to our needs and literally be making developmental improvements as we speak. Week over week, we see those improvements happening. And that's huge. That's huge. That's going to be a game changer for us and I believe you in the long run.
Yeah, thank you so much, Jesse and Cole. That's the problem, right? So I think a lot of the solution providers in our industry focuses on serving the bigger guys. I will argue, as you're going to national level as a firm, you're big enough to be able to afford a software team internally. So are they the one who are in desperate need for automation / software solutions? Probably not. Those relatively small and scale firms are the ones often getting neglected by the solution providers, which is one of the main missions I want to address. I want to dive a little bit deep into one aspect of our processes, right? So basically we use our system to pre-generate the initial design, and Cole in this case help us review the drawings, refine them, and improve the drawing to where you feel comfortable putting your seal on it, right? So that's been the process that we have been collaborating so far. One critical question that I keep hearing is not all structural engineers in our industry are forward thinking like you guys. Some people are skeptical about the usage of AI. But on the other hand, we keep hearing the notion that AI is going to replace structural engineers. Is those structural engineers who use AI will replace those who don't. Tell us a bit more about your approaches collaborating with AI. In particular, how do you hold the engineering standards with a design that's pre-generated?
Luckily, as structural civil engineers, the code dictates to us what the calculations are. So,
Right.
provided your system isn't using AI to create new equations and it's simply just using
Or
the
not.
equations that the code actually already provides us, then
Exactly.
your AI really isn't doing the job of the engineer in that respect, right? It's just trying to follow the loads through the load path. It's figuring out the geometry very quickly and allowing us to not only apply the loads to that geometry, but potentially show. Usually, your system will give us like 3 framing options. Like you can change the direction of the framing, and you can quickly see the results of like what that would, how that might improve for cost stability or constructability. So when you're leveraging the AI in the way that I believe you are, which is more on the cost benefit analysis for the different framing methodologies and orientations, that's a huge benefit. As long as it's not hallucinating equations and it's just applying the code equations as it's written, then that's not much different than the way that I have it already now, right? I mean, I have to
Right.
actually try to take the code and put it into my Excel spreadsheets, but it's my job
Sure.
to like grab the code and put it in there and bet that it's working correctly. So in this case, we've done the same thing. We have calculations over here that we've vetted over time. We compare it to your calculations. We see that they match, at least reasonably, within small, when you're doing FEA analysis, some of the numbers start to come out slightly different. But on the whole, they're basically apple to apple, and you can see that you're getting the same result. Then it's kind of quick to check. But at first, what we did is we literally kind of ran our own analysis and looked at it side by side with your analysis to kind of help us vet each of the components and making sure that your beam equations are running correctly. But your visualization is really helpful. Your calculation package shows what the wind surface areas are, what your loads are, how that flows down, what the moment and shear diagrams on your beam equations are. It looks a lot like what you would get from like an intercalc output. So you can kind of quickly compare it to an intercalc output, not to pump them, but I can side by side check them and then vet them and become comfortable with it. And that's how all things, if I had an EIT doing all of this work instead of your AI tool, your AI tool is far faster, but I would still have to vet all that information. I'd still have to check it against something, whether or not that's a hand calculation or I'm using something that I know works, consistently. It's a lot slower, but I can still vet the stuff. And that's what we've done. We've vetted it. And now we feel very comfortable about certain aspects as we make improvements. So we say, hey, we want to do force transfer around opening lateral designs. You developed that. You added it in there. We compared that to APA established processes and calculations. We see that we're getting the same results. Awesome. Now we've kind of got that figured out. And now because the computer does the same process over and over again, you can now quickly check it later because the output all looks the same. It's the same thing where I have 5 different engineers doing different projects. They all give me different output, and it's really hard to check because one engineer is using AirCalc, one's using Reset 3D, one's doing hand calculation, one's using ETABS, and every time I look at it, I have to look at different formats. Your system gives me the same format every time, and so once I've seen that format over and over again, it's quick to check it because I know where everything is. Here's my loads. Here's my load path. Here's how your beam goes to your column, goes to your foundation. I can see the callouts. And so after you've done it a couple of times, you can see the flow really fast. You can start checking it really fast because you have a consistent output. And that's important.
I have been asking myself, am I still exercising the same level of control over this design using Genia's tool as I would if I were doing the calculations by hand? And when I ask myself this question, the same thought keeps popping up. And I am sort of making this analogy to the advent of computerized drawing software. It can exercise the same level of control with less effort. So let's say, hypothetically, I'm drafting something by hand and I screw something up. I got to rewrite the whole thing. I'm probably getting fired back in the 60s. But nowadays, I can bang out another 12 different designs. And that's only possible because of your system.
Absolutely. FTAO was actually a very particular example where I think under your help, we were able to quickly add as a missing piece. And I think through our collaboration, in particular, thank you to Cole for providing feedback on what should be put on our roadmap. I think that collaboration.
Yeah, I mean, at the end of the day, they're my calcs. So it matters that they're right. That's the goal.
Exactly. Absolutely.
One thing that it does is actually add value to your client. Because you're able to develop this further and add more cost value analysis within your software, it's going to add value to the client. And ultimately, that's what we're trying to do here. And the client saves big time because compare that to a segmented shear wall or any other shear wall design, frankly, you end up with a lot more hold downs, like prescriptive method. Prescriptive method,
Exactly.
every little 4-foot segment, every 25 feet has 2 hold downs and all this stuff. If we do force transfer about opening, suddenly we're able to remove the vast majority of these hold downs. And the cost of installing hold downs is big, especially on a simple floor plan like this. So if we can draw and take out 12 hold downs out of this, and maybe we only have 2 or no hold downs on the entire design, suddenly we've paid for our engineering just by doing that. And the frustration of doing that and then getting an inspector to go inspect those items because those are inspection items. All of that starts saving the client effort and money. So I think it's a value add.
Absolutely. These hold ons are expensive. They cost a couple $100s.
And they've got like 26, screws and stuff. So I mean, they take a while to install. They're not cheap to get. Then you have to inspect them. The whole process is cumbersome. So if we can eliminate a lot of them, that really helps.
Exactly. I want to switch gear a little bit to talk about AI's future in structural engineering overall. I want to, in particular, pick your perspective on 2 things. One is, what role should AI play in the overall structural design process for similar firms as SML? Cole, I'm in particular interested in your perspective on the career development side of things. So for any young engineers entering the workforce, should they embrace AI? Should they be afraid of AI? What's the best practice around AI usage?
So you kind of said it earlier, and I do believe that it's true, that it's effectively a tool. And if you can do your job more effectively and faster and add value to your client, then you should probably use that tool. I think that the tool will gain value over time as well because of all the advancements, right? And computer processing and everything. So it will get better over time. We've already seen that just in the last 2 years. It's gone from more a conceptual thing to an actual, I mean, we're doing it now. We're live. So I feel like it's going to end up being the wave of the future. We will have some fight back against it because of just how you control all of the data that's produced from this stuff and who owns that and everything. So I think there will be a struggle. But I think overall, those firms that embrace it and utilize it as the tool that it is, treat it kind of like an EIT, right? You got to check everything that goes through it. But because the EIT is giving you consistent feedback over and over again, it makes your checking process very quick. And so I think that's where it's going to really add value. And I think we're going to all need to kind of go that way. I'm 50 and I'm still got a while before I can retire. So I have to go all in, right? I need to add value to my firm so that when I go to retire, there'll be something there to kind of sell, hopefully to Cole or other people within our firm. And if I were instead 60 and I was retiring 2 years from now, those guys are going to be very reluctant to try to learn this stuff. So what I would suggest for any of those firms is get your young whippersnappers that have a propensity to figure this stuff out, get them, the ones you can trust, and bring them up through your system and have those guys be your liaison for utilizing these tools and teaching everybody else in your firm how to use these tools. You don't have to necessarily take it on yourself. I know if you're just a couple years from retirement, that's a big ask. It was hard enough for them to learn how to use AutoCAD and just use computers in general because everything was done by hand for that generation. And now everything is done by computers, but it's kind of going one more step further.
For a young engineer, as long as you are practicing ethically, you're doing the things you should be doing, AI is just another means to an end. It's another way to get the job done. And if you find ways to do the things you need to do quicker or better or faster or using AI, then yeah, like Jesse said, that's the way you should go. If it helps your standing at your firm or if it helps you accomplish the things you want to do with less energy, then yeah, certainly do it. I heard a term recently, cognitive surrender, meaning that you are no longer willing to put in the effort to solve the problems and you'll let the AI do this problem solving. But it's not really problem solving if you don't get in and try and interpret the results. So to that point, as long as you are still trying to understand and interpret what you're getting, it doesn't really matter how you're doing it. It will matter because if someone does it better than you, you're not going to do well. So that's where I'll leave it.
Just like the FTA modeling software, you can model things incorrectly and get really crappy results. It's the crap in equals crap out philosophy, right? If you don't put in the right crap, then you get really bad crap out. It's that same thing. So FTA modeling was a long time the same scenario, where if you didn't know how to use that software, then the results that you got weren't really valid. And a lot of people ran a lot of hand counts to see those reactions that I'm getting, those moments that I'm getting in the FTA software. It makes sense. You have to do the same thing here. It's really no different with each step in technology. So I feel like, it's just one more tool in our tool bag. Let's go ahead and use it as it's intended, which is as a tool. And again, treat it like an EIT or somebody that you have to vet all their work anyway. It's not going to make the final determination for anything. I think that one big advancement that's still going to come down, and I think, we kind of mentioned this before, is error checking. And I know there's another firm out there doing a lot of error checking, especially with code compliance and things like that. I think that's where AI really shines. It can really kind of spot those things much faster than we can. And they've shown a lot of studies recently that is probably where it might be the most advantageous for us, is to just try to help us find all the errors, the conflicts between our drawings and the code, those allowables. And now with like ASCE, they have their own, I think it's called Atlas or something like that, or maybe that was the Steel one, that they have their own AI kind of software that has multiple of its standards all inside it. So you can go there and ask questions. I think eventually that will become an ecosystem that you can kind of tap into. The Steel one, the Steel has one, ASCE has one. I'm pretty sure they're all going to have their own little way that you can quickly go access the code and then do code compliance checks. I feel like that's going to be a major advancement that everyone's going to be taking advantage of. And if you don't, you're kind of missing the boat, because if you make an error, that's where the cost can really come to bite you, right? Exactly. And if you can avoid that really fast, and you still put your eyes on it, so I'm not saying don't do that, but you can get to find a lot of the errors a lot faster.
Absolutely. I want to echo on what Cole said earlier, which is when we spoke with similar engineers, one concern people expressed was this AI tool is going to introduce some experience gap, right? So if they're doing what the EITs usually do, then what kind of opportunities would they find to grow their engineering acumen, right? But Cole, I think you're a perfect counterexample to that. You grew up in the automation stage. You have been developing your intuition, your engineering judgment by iterating a lot faster. So just want to mention that.
Things are changing quickly, and I need to add value as much as I can.
Yes, I just want to revisit another topic that you mentioned briefly, which is around the data exchange model. We did something spectacular, right? So you guys were able to share your general structural nodes and detail libraries with us, and we have them pre-configured in our system under a private licensing model. Can you tell us a little more about that model? Do you see that as a potential to become an industry standard?
Well, definitely for our first agreement, which was, we now have a standard in your system that you use for us. And that's great, because it allows us to get basically what we're familiar with back out of your system, so that we don't have to try to vet some other version of a general structural note package or some other version of details. They are our details. They are our general structural notes. Now, whether or not we go further and we license that for other people's use, I would love to entertain that. I don't know that ours is perfect, like anything, right? There's slightly different versions out there. So whether or not other people would want to go with ours when they have their own standard as well, I feel like it would be great if you had an opportunity for each engineering firm to upload their own GSN and their own details into your system that you just feed back to them. If you could kind of introduce a way for that to happen, where they go, you can use the default ones, that's fine. But if you have your own, upload them here, and we'll kind of regurgitate them back to you for you to use. And I think there's a way to make their dynamic expressions within the general structural notes and in the
Right.
details so that they link to the plans. And this is one thing I'd love to be able to further develop with you within
Sure.
our set. And I think others could apply this. And that is if you cut a specific detail on the plan and it has a certain type of product in there, maybe it's a concrete anchor detail, then the general structural note for that automatically gets applied in the general structural notes. And it kind of
Right.
whittles out certain general structural notes that might not apply to that plan so that you don't have 10 pages of boilerplate general structural notes and no one's going to read it because it's just too much, especially on a small little project. So I really think
Exactly.
there's a dynamic process that can happen there that general note always goes with this detail or whatever, and they come as kind of a package, or they kind of get eliminated if you don't need them. I think that could add a lot of value because we go through that. I mean, sometimes I'll spend 15, 20 minutes, a half an hour going through our general notes at the end just to make sure that I weed out all the stuff that's not applicable because I
Sure.
want the contractor to read my notes. I don't want them to look at them and go, oh, it's just boilerplate. I'm just not even going to bother, even though it's their job. But, if you make it too convoluted and they're having to pick out only 1/10 of that even applies to their job, then they stop
Right.
reading it. They're like, well, I know that doesn't apply. And so they miss stuff. So that's where I think the dynamic process within your system could really add value is to get a very customized output for a very specific project.
Exactly. That's a dynamic configurable template that we're currently working on together, right? So not only just a tagging system with the details, but also make it configurable as a template and pull in the relevant details only when they occur, right? So that's the idea.
Exactly.
All right. I probably want to wrap up this recording with one or two last questions. How do you see our model evolve over time? Do you see us expanding beyond ADUs to cover custom homes,
There's
traction
no
homes?
doubt in my mind, yeah, that we've been able to scratch the surface of something that we thought was unscratchable, and it's only really a matter of time until you do what you just said. Yeah.
Let's go ahead and crack that multi-story nut. And then suddenly now we have the different roof configurations, we've got several of them already under our belt and the details that go with them. We get a
Mhm.
lot of mixed roofs out here where we'll get some slope roof with some flat roof and some combination. Once we can kind of get those combinations in your system to kind of agree with that, then I think you're into the custom world market very easily because an EDU has all of the components of a custom home. It's just that the custom home is much bigger and maybe it doesn't have it has a detached garage, but that's just another room with a big open. You have the beam, you have the column, you have the foundation. Now you're just rinsing and repeating it multiple times. I think that when you get into like apartment buildings and things like that, then I think it's just the next step, right? I do think that as we add levels, we're going to have to add more shear wall options and things like that because you get down to the first level on a big tall building, suddenly the demand for those shear walls goes way up to the roof. So now we have heavier hold downs and things like that. But the process really doesn't change. It's just changing from one hold
Sure.
down to a different hold down. Maybe the post instead of being a 2 by post, now it has to be a 6 by post because it's a super heavily loaded post or something. But
Right.
it's still a post. I don't really believe that expanding out is going to be that difficult. But I think starting small allows you to kind of perfect something when it's easy to perfect it. And then as you expand into the more complex, it makes that expansion that much easier to do. Trying to start with the
Exactly.
5,000 square foot custom home with
Mhm.
basketball court and 2 levels right off your first job is a hard thing to do and a heavy
Right.
lift. But if you can kind of perfect these other ones and work your way up to that, soon you'll be doing those. I really feel like a year from now, we'll be doing those types of projects.
Gia, you'll be happy to hear that I got a job the other day, and my first thought wasn't how I would do it. It was how could I have Genia assist me with the project. So congratulations, you've become that important to me.
And we've been selling it internally. We've told our other engineers, hey, we've already successfully done 4 projects. We believe right now it's fully capable to do these ADU style and detached structures, both shade. We could probably, I think, step into the open shade structure. I think once we can kind of
Sure.
get it to where it's partially open, and I think that Full House was like that, right? Isn't that
Right.
right, Cole?
Yeah,
Partially open?
it's close.
Yeah, then we can step into that next phase and suddenly
Mhm.
we're doing whole build, like very large buildings, and it's just around the corner though. Like I said, a year from now I feel like we're
Exactly.
going to be doing custom homes and probably like 6-story wood
Okay.
structures. It'd be interesting to see if you can get into the cold form steel as well, but that's a whole different detail set, a whole different GSM, you know So, but the methodology really isn't drastically different. It's just the connections are quite a bit different for that.
Full disclosure, CMS is probably on our next year's roadmap. I don't think we're able to get to that this year, but we were definitely eager to
It's
work on
hard.
that.
We did track homes. I did track homes for 6 years, and we talked about
Right.
doing CFS, and the difference in the calculations is kind of dramatic. For your fastener
Exactly.
and everything, all the connection detailing is completely different. You basically have to come up with a whole different set of detail database and a whole different set of
Right.
connection calculations. The overall methodology for lateral and gravity, the load paths don't really change, but each little cripple zone and stuff has to be checked in a much more dramatic way or expansive way.
Absolutely. For home builders, architectural firms who want to work with us, how do they engage with us?
Well, if they're coming through us, then we'll definitely, if we feel like it's a good way to go, we're going to use your tool. When you find one of these developers or architects and you want to bring that to us, we're wanting to partner with you on those. And so I do want to kind of keep going down that road. And that's kind of where we've done a mixed bag so far, where some of them are we bring to you and some of them you bring to us. And I'm open to
Right.
both those opportunities. I think it's great to actually have some work flowing in from you guys and the other way around. Like it's, we're both giving and taking care. This is really great.
Cool. For anybody who needs quality structural drawing done faster, do reach out. We partner with amazing structural engineers like Jesse and Cole, both gentlemen on this recording here. We are dedicated to holding the same engineering standards as well as getting those jobs done faster with a very much predictable timeline. Cool. It's a great pleasure having you both on this podcast. Thank you so much for taking the time. I just want to express our gratitudes for your support, both working with us, helping us develop the systems, as well as for our collaboration on the previous projects and onward. Thank you so much, Jesse and Cole.
It's been great to
Thank
meet
you.
you and then I'll work with you. Thank you so much. Have a great day.